Alright, hello and welcome back to our lecture slides on files and streams. Let's keep on trucking. We're ready for this. So I want to tell you a little secret. The way that I want you to think about how files are being read when you're using IF streams. So think of it like an editor, like Microsoft Word or Google Docs, something like that. All of those things have like a little cursor where you're ready to type, right? That's essentially what's going on when you use an IF stream. When you open it up, it starts out its little tiny cursor at the beginning of the file, and that's how it knows, okay, I'm ready to read from here onwards. Next, yeah? I'm ready to read that foo, because that's where my cursor is. And then, if you read in a string, remember that reads a single word, it eats it up, and then moves its cursor, so that it's ready to read the next thing. That's how it's working as it's reading a file. And so if you read another word, it's like, I read the bar, bloop. Now I'm done reading bar. If you read another word, it's like, okay, I'm going to eat up any white space, get to the next word, I'm reading Baz into S, and then my cursor is at the end of Baz, right after it. Read one last word, and it's like, okay, eat up any white space, get to the start of the word, read the word into S, and now the cursor's here at the end of the file. Okay? That is how that works, and that's how I want you to think about it, okay? That's hopefully not too bad, and that kind of keeps track of where you are. That's how you remember, okay, it really is going through the whole file, and it's going to read the whole thing in order. Okay, so here's an example for you. Let me accidentally read after a file is over, because once I've read all these words, actually, we haven't yet noticed, IFStream hasn't noticed that we're at the end of the file yet, surprisingly. And so something that you can do accidentally involves EOF, and that is why I would prefer for you to read in the condition. Okay, I'm going to prove to you why that's better than checking EOF, because EOF is not true when you think it's true. Alright, so let me make like a sample file. Sample file.txt for us to read. Foo, bar, baz, blah. It's the one that we were talking about. So there's my file. It exists. And here's what I want to do. Let's kind of do what we just did. Read those 4 characters in, eat them all up. I don't know, EOF.cpp. Something's going wrong with it. So I'm going to read this file. fstream, and then I'm going to, well, let's kind of copy all of this as much as we can at least. Copy that. Gonna have to change a little bit. Copy these 2 things. And so there were 4 words in that file. Let's read them all. Read 4 words. And now I'm going to output, hey, is IFS, has it seen the end of the file? Does it think we're finished with the file yet? And I guess I was supposed to call it sample-file, but what did I call it? No. I called it sample file like this. There. So let's recompile it that way. And so now let's run it. And what do you know? I've read every word in this file because it's got 4 words. Oops. There. It's got 4 words, but the cursor is sitting like right there. It hasn't noticed the end of the file. It's right up next to it. It's like there's a special character right here called EOF that it hasn't seen yet. Okay? That's what's happening right now. And so EOF is false right now. Crazy. It is false. How dare it be false? But that is what's happening. So, yeah, let's check for EOF and keep reading if it's false. Okay? Something like that. Let's check for EOF. Let's just do the way we just did. After reading every word in a file, the issue is we need to try to read once more to notice the end of the file. Here's what's going on. Here's like the last word in the file, and after you read it, the cursor is right here, but the EOF, the end of the file, has not yet been reached. Okay? Crazy. So when you try to read one last time, you end up reading past the end of the file. That's when it happens. Okay? When you do that, it's like, okay, I'm going to try to read something, and it's going to fail. It's like, okay, I finally noticed EOF. It's not going to change anything. It's not going to change your S variable. It will not get reset. I'm going to show you an example of that. You're going to end up getting a copy, and that is very unfortunate. Okay? So let me show you that happening. So, this is the idea. IFS. Get one more thing, right? Now EOF should be true, right? Read past the end of the file. Try to read one more word. There is no more words, so we're going to read the end of the file. Now it's true. But what do we think S holds? Anything special, like empty string maybe, because it read nothing? It still thinks it's the last word. This line notices the end of the file and does not change S. That is tricky. Okay, that's what I want you to remember. So this is not going to fail. It's not going to cause a runtime error to read the end of the file. It's going to do nothing to S. It's not going to set the variable that you wanted it to be set. It's going to notice the end of the file, so 1, but it didn't reset S, so it's still the last word that we got from this line. That's the last time S was reset. Okay? That is unfortunate. That is sad. And so you kind of have to keep on checking. Once you read past the end of the file, you kind of have to keep on checking if you're going to do that .eof way. You have to be very careful about accidentally using your input variable, because it's not going to be anything special. It's going to be just the last thing that you read normally. So after every read, you better check, hey, did I hit the end of the file? If so, S is useless to me at this point. Okay? That's the old value. And so that's why it's much easier, much better to do it this way. While IFS, read into S. Because this will not cause, this will stop the body from being executed. This will become false the second we've read past the end of the file. Okay? That is much better than constantly checking for EOF. Okay? But if you do it this way, you have to check after every read, hey, did I hit the end of the file? Can I use that S that I thought I got? Because sometimes you didn't get it. All right, I hope that makes enough sense. So with that, let's move on to a fun example that I like to give in my classes. Usually it involves audience participation, so we're going to have to get a bit tricky with this, but here is the idea. Let us translate the words to Let It Go, because that's our favorite song. So I have Let It Go lyrics.txt, here they are, and what we're going to do is we're going to make a translation program to translate some of these words into other languages that we know. So like we can translate snow into nieve or something like that. And so let's have fun with this, and it will give us practice with reading files and outputting them. Okay? So here's what I would like to do. I guess I'm going to need to like translate stuff. So like translate.google.com. Let's sit there for a little bit. I also need fstream stuff because we're going to be inputting stuff from a file. Okay? So let's read the lyrics and translate some of the words. Doesn't that sound like fun? So let's set that up. And I think that'll be interesting. We're going to translate some of the Let It Go lyrics. Alright, so I guess I need fstreams. Let's open the file. Sorry, ifstream. IFS. And we're going to give it the file letitgolyrics.txt. I think that's what it was called. And then we're going to remember to close it once we're done. And yeah, in between, we're going to get a word at a time, repeatedly get words. So like, I don't know, string word. I need strings now. Then we're going to say while getting a word from IFS into Word is true, let's, I don't know, see out the translated version of, I'll make a translate function. See out the translated version of that word. Something like that. Maybe like a space after it. That should work. So that's the kind of game that we would like to play. So translate needs to take a string, give back a string. We can take it by const reference, and we'll translate it. So let's just pretend that, I don't know, we only know Spanish. And so we'll translate snow to nieve, and everything else we don't know how to translate, so we'll keep it the same. So it'll look like this. So if S is snow, then we want to return the Spanish translation of snow. Otherwise, we'll just give up and be like, return the original string, a copy of it. I don't know how to translate that word. So this is a nice start, right? But it's going to look a bit weird, and we're going to fix that. There it goes. And so the issue here is working. Like, it translates snow to nieve every time it sneezes snow, but like the format of the file is all messed up. You see that? That's no fun. We want the file to look kind of like how it was given to us. Like there should be an enter after this line, a new line, some new lines. Like this is a new stanza, so we need an empty line. We would like to preserve the existing white space of the file. Okay, that's what we would like to do, and there's a way to do it. If we want to keep the same characters, the same white space characters that the original file has, we are not going to get very far by just doing this, ifs read a word, because that eats up white space before the word, right? We don't like that. We want to preserve the existing white space, so we need to notice it and keep it around, okay? So not a bunch of spaces, but preserve the white space. Okay, so let me kind of show you how to do that. We're going to need to use ifs.peek and ifs.get to deal with our white space, because that will allow us to read a single character at a time. So get and peek, let's look at both of those. So if you say .get, that gives you back a single character. It extracts a single character, and it reads just that one character. And that will let us read a single space character, or a new line character, or a tab character, one at a time. Unfortunately, that will move the cursor and eat it up. We don't want to read the next character if it's part of a word. So we're going to have to do something different. So like, let's say, here's where we are. We would like to read a single character of the word blah with our cursor right here. We can say get. Get will give us that single character and eat it up and move the cursor. Or we could use peek. Peek. If we called peek right now, it would give us back L, but it would not move the cursor here. That's the secret. So we want to use peek to see if the next character is... It returns the next character in the input sequence without extracting it. That will give us the ability to look ahead and see, hey, is the next character white space? If so, let's eat it up with get, and then preserve it in the output. Okay? So here's the idea. Here was my original cursor. Here's an example of both. So let's say that the cursor starts out right here, start of the file. So if I said ifs.get, right here, with that cursor there, it'll give me back the B character, and it will also move this cursor. Alternatively, if I said ifs.peek right now, it will give me back the L character, but it will not move the cursor. Doesn't move the cursor. That's quite nice. Okay, so with that in mind, we can eat up white space right here. So we'll read a word and then preserve the existing white space. Output its translation and then preserve all the white space after the word in the file. So what we'll do is we'll repeatedly peek, okay? While ifs.peek the character that we see by peeking is a white space character. So, is space, well, this is true. Then, we would like to eat up that space character, because we know that the next character, we peeked ahead, we saw that it's white space. We gotta use get to get it. And then, we will output it. Because sometimes it's a space, sometimes it's a new line, just whatever we got, give it to cout. And this will keep the same space characters from IFS. So if it was a space, output a space. If it was a new line, output a new line. If there were a bunch of them, we're going to continue this loop until we see a non-space character, because that'll stop this while loop. And then we're ready to read that word again up here. Okay? So it is a nested loop, but I hope it makes enough sense. Okay? That's the trick. It'll preserve our white space. Boop. And there we go. Much better. So, the nieve glows white on the mountain tonight. Let's translate another word. Usually I'd be asking my students for this right now. So let's translate mountain. That's easy. We can do French. Montagne. Sounds the same as in Spanish, but it's spelled differently. Oh, sorry, if S is mountain, then we want to give back the French translation. Boop. And then let's do one more for good measure. What's a good word? We can do it at the start. How about kingdom? Kingdom of isolation. Let's translate that to, I don't know. Something fun that it doesn't involve Latin characters. Let's just do like Japanese or something. Yay! Okoku. So if we see kingdom, please translate that into this string. That is the Japanese translation. Totally allowable in C++ to have special characters like this. And so that's probably as far as I want to go, but a good example program, I hope. So translating things, reading a word at a time, translating its output, translating it and outputting it, and then eating up all the space characters in between. And so now we have, if I scroll up to the top, oh no, oh sorry. If S is equal to, no, did I not recompile maybe? That would do it. Or maybe I scrolled up to the wrong place. I sure hope it worked. It looks better to me. So, yeah. The nieve glows white on the montagne tonight. Okoku of isolation. How fun. Okay, so that's a nice little involved example. And that should help us as we're learning about files. Okay, I have another fun example that combines reading files and writing files. Okay, so let's make a cp command. Okay, a cp command, that's the copy command, right? You use it like this: cp file1, file2. That copies one file into another and calls it file2. Copies file1 into file2, we say. So let's use one IF stream and one OF stream to do the same thing. And we'll read a character at a time and give it to another file, okay? So take the first file, copy it into another file. Won't that be nice? So yeah, let's use one IF stream and one OF stream, one to read the original, one to write the new file, okay? That'll be our game that we play here. And so we'll use ifs.get to read a single character, and then to write a single character to an output file. The corresponding method is called put. So you get a character from the input and you put a character into the output. Okay? So that'll be fun. So we'll call this cp.cpp. And we can hard code the file names. We're not going to be too fancy today. So I need an IF stream to get the input file. What's a good file that we would like to copy? Maybe we can call it I don't know. Let's copy sample file. Or you know what? Well, let's just take it by command line arguments. Let's have it so that we can actually use it like CP could be used. So watch this. Char star argv bracket bracket. So if somebody ran our program like this, /cp with file1, file2, where is file1 in argv? It's argv0, argv1. Argv1 is the name of the input file, and argv2 is the name of the output file. Isn't that cute? So let's just assume those exist. We're not going to warn the user if they did it wrong. We'll just get a segfault. But this will work for us. So open the input file. There's its name. It was in argv1. Cool. And then let's open the output file for writing. You can translate a C string into a normal string on the fly like this. That's useful. And then what we're going to do is read a character at a time and give it to OFS. Okay, so while, I don't know, while true maybe? That'll work. So while true forever, please read a character from IFS, put the character into OFS. So char c equals ifs.get, gets a single character, and then we're going to put it into OFS. Those are working hand in hand like that. The one thing that could happen, though, is we hit the end of the input file. That's when we want to stop, okay? So here we go. So if we hit the end of the input file, if ifs.eof is true, then we want to break out of this loop. We're finally done, okay? Otherwise, we have a real character to add to our output. And after that, we can close them. Done with IFS, oops, and done with OFS too. Okay, so that's the copy program. Copy one file into another. Won't that be fun? So let's copy sample file.txt into sample file, let's just call it copy.txt. So it ran, it made that new file, hey, and let's output both of them. So sample file looked like this, and then sample file copy is the exact same thing. Oh yeah. And so we copied it one character at a time. That's a fun little example too, I hope. I just have a bunch of those cool examples today, really. So let's keep on trucking. Let's move on to something called string streams. Okay? This is going to be useful to you later. A string stream is kind of like cout and cin and ifstream and ofstream kind of combined. It's really cool. It's like your own personal cin or cout. That's how I would call it. And let me show that to you. You can build up a string inside of a string stream using the input, or using the give data operator, and you can get stuff out with the extract data operator. Okay? So it lives in the stream library, and you make a string stream like this. This is the name of the type, string stream SS, and then you can fill it with stuff, which is kind of cool to think about. Let's go to its header. Boop, boop, boop. So it's an stream here. It's the string stream class, and you can both extract stuff and give it stuff. It's like cin plus cout together. It's building up a string for you. So here's what you can do to your SS. You can be like, SS, please take the number 100. Please take a new line. Please take the number 200. That's kind of cool. So that will do this. That will build up a string inside of your string stream called SS that holds exactly what you typed. 100, 200, it's got all that there. And also, in addition to being able to write to your string stream, you can read from it. So I can say something like int x, and then read into x from the string stream. So it's like the cursor was here. Now I read into my x the first number, and the cursor's there. That'll set the x variable to 100. So isn't that cool? You can build up your own string inside of a string stream and also extract from it if you would like. So you can also extract the entire thing that you've built up, ss.str. That gives back the whole thing that you've built up, the whole string you've been building inside of your string stream. That's the 100 new line 200 string at this point. But that's kind of cool. It's like your own personal CNCet. Okay? So, with that, let me just show that to you briefly. Yeah. So, it's called SStream to include it. But the type is called string stream still. And so let's give it stuff. Let's give it 100, 200, and a new line in between. And so we can now extract from it. That'll get the 100, put it in X. And we can also get the string that we've been building up and give that back too. That's ss.stir. Isn't that neat? So you can build up a string, and you can also take stuff out of it. It's like cin and cout at the same time. And you can also, of course, get out the string that you've been building up. So that's string streams in a nutshell. They will come in handy one day for you, so that's why you're learning about them. And now I have something that I would normally give you in class. This is an extended crushed ice. So feel free to try this. Like, I am going to give you this file in the code from class for today. It's called Swedishwords.txt. Take a look at it. Here's a bunch of space separated or new line separated Swedish words, and let us randomly generate IKEA product names from a list of these Swedish words, because that's essentially how they generate their names, right? So yeah, take this list, read all the words into a vector of strings, and then to generate a random IKEA word, here's what you can do. You can pick 2 random words out of your vector of strings that you got from the file, and just like plop them together, concatenate them, and that's the name of the cool IKEA product for spring of 2022. Okay, so give this a try. It's a really fun example, and you come up with some very convincing looking words that could probably be an IKEA product. So yeah, let me show this to you now. Yeah, so that your goal is read all your words into a vector of words, A, B, C, D, and then pick 2 random ones, like, I don't know, index. This is the first one that you randomly pick, and this is the second one that you randomly pick, and then output their combination. Okay? IKEA.cpp. So, I want to read all of the words in the file, so fstream, into a vector of strings, so string and vector, also necessary. Here we go. So let's open the file for reading. It's called Swedishwords.txt, I think. Let's remember to close it once we're done. And let's read all the words into a vector of strings. So string s, or string word, vector of string words, and then while we read from IFS into a word, and that worked, put that word into words. So that should read every word in the file and give it to the words vector, and then we're done with IFS. We don't need it anymore. We can close it, and then we can do the rest of our work. Pick 2 random words from the vector and print them out. So I need cstdlib and ctime as well, right? So I need to seed my random number generator. And now I want 2 random words from the vector. So, I don't know, string word 1 is go into words at a random index that is valid. So what are all the indices that are valid? It's all the numbers, all the indices between 0 and the size -1 of the words vector. So here's what you can do. You can get a random number and mod it by words.size. That'll give you a number between 0 and the size -1. That is a valid index. So that's word 1, here's word 2, and then we're just going to output them together. And that is our hot new IKEA product. Okay? That's kind of cool. It's a fun little example. Yay, so this is my random product name that I came up with. Here's another one. Like, these totally look like they could be sold at IKEA. That's on their tag. I won't pretend to know how to pronounce any of these, so you can just read them in your head. Yay, so yeah, I'd buy all of these. So that's a fun little example too. That is my game today, just giving you a ton of cool examples because files are a fun subject. Alright, my last example is probably the coolest. I'm going to teach you how to read files that contain images. Okay? So before we get there, I'm going to open up this slide because there's a special format that's easy for us to read. It's called I think it's Ppm Format. That's what we're going to have here. And it's going to look like this. That's essentially the format that we're going to care about. So we're going to zoom in there and come back to it. But first, before we get there, let me talk to you about images, just in case you're not very familiar with how images are stored on a computer. So let me teach you some terms. I'm not going to test you on this or anything, but you might care. So every image that you have on your computer is made of a bunch of squares, right? Just a bunch of pixels, and each pixel is a single color, right? It's not, that's the illusion, right? We zoom in, everything is either one color or another. Where's my image? There it is. And so just a bunch of squares of a single color combined together make up one cool looking picture. And so every image has a width and a height, and every single pixel, every single color is represented as 3 numbers. It's a triple of numbers. How much red is in that color, how much green is in the color, and how much blue is in the color. And the red value, the green value, and the blue value, those are all numbers between 0 and 255, which is nice for a computer. Alright, so it's called RGB. How much red, how much green, how much blue. It's an additive color system, so all of them together, 255, 255, 255, that is pure white. All red, all green, all blue, that's white. And then none of any of the colors, that makes black. Okay, so that's the idea there. And then just arbitrary colors. There's some amount of red, some amount of green, some amount of blue. Also, following this pattern, like this is white, this is black, there is a pattern there. So if the red is equal to the green is equal to the blue, that makes a shade of gray. So there are 256 shades of gray in RGB land. And so that's what we're going to do. We're going to convert an image to black and white, or not black and white, grayscale. Only grayscale. Only shades of gray. So to get there, here's the kind of file that we're going to use. It's going to be the Ppm format. It's a file type that stores images. Okay? So what you do is you give all the RGB values as text. So it's not a very efficient format, but it's useful for us. So here is my example picture. It's called this right here, cat.ppm. So I have a picture of Lonzo, my cat, encoded as this file format. And so here's what it looks like. It's like, this is the header, this is how big and wide the thing is, this is like saying that I want RGB format. So these 3 lines are fixed. And then the rest of this is all the pixels of the image. It's like this much red, this much green, this much blue in the top left or something. Here's the next pixel in order, next pixel in order. So our job will be to read all these pixels and change them a little bit, okay? Because right now this is what it looks like. This is Lonzo. Yay. So a nice picture of him as a kitten with a bunch of colors in the image. So he's laying on my running shirts. So we're going to change this around. We're going to convert colorful Lonzo to grayscale, okay? So that's the idea. So that's the Ppm format. This is what it looks like. Here is what these like all mean, and then here is the contents of the image, okay? All the pixels. So that's what we're going to do. we are going to read, check the time, yeah, we're doing all right. We're going to read a pixel at a time and convert it, okay? So here's how you can do it. We're going to do grayscale. So if you read a pixel, you get a red value, a green value, a blue value, right? And our job is to translate it to the closest grayscale value. And the way that you do that, one way to do it that's easy, is to just take the average lightness of each of these pixels, because like if it's super bright, it's close to 255, it's close to white. If it's super dark, it's close to 0, which is closer to black. So we'll just average together all of those values, R plus G plus B over 3, and that's the pixel that we'll replace this with the average 3 times. And because they're all equal, that makes a shade of gray, and that's the closest shade of gray for some definition of closest. Okay? So we'll replace each pixel with the average to make a grayscale image. Won't that be fun? So let's make a new C++ file, gray.cpp. And so here's what we're going to do. We're going to read our file, one line by one line, for a little bit. So I'm going to need, strings. I'm going to need fstream to actually read the file. And here's how we'll do it. So we're going to, again, we have to get the file. The file name is cat.ppm, right? So let's open that with an ifstream. And then we have to also output a new image file with an ofstream. cat.gray.ppm, let's say. So that needs to happen. Both of those need to happen. And then we want to preserve this image, right? So let's take a look at it. Here it is. These 3 lines are fixed. We need to preserve the original 3 lines. So let's just do that right now. Because those are just needed to say how big the image is, like it's the proper format and all that. And then every line starting on line 4 is when we read red, green, and blue and do our stuff and translate. So let's preserve the original 3 lines. So string line, let's just get them all. Be like, get line from, instead of cin into line, we're going to get it from ifs. That also works. So that gets a line, and then we're going to give that line to, not cout, ofs. Put it in that output image file. So we're going to do that for the first 3 lines in the image, and then we're ready to get RGB. Okay? Until the end of the file now. Okay? So we're going to get a single RGB value a bunch of times and convert it. And so the easiest way to do this and stop at the end of the file is to read into these values in the condition of a loop. So while reading from IFS the image, give me a red, give me a green, give me a blue, while that works, then let's process that and give it to the output image. So we're going to compute the average equals red plus green plus blue over 3. Integer division, of course. And then we're going to give that pixel to the image, to the output image. So it's got to be red space green space blue. That's how it's encoded, and then a new line. So that's how we'll do it. So we'll give to OFS average space average new line. Okay? And that should do it. Then I'm done with IFS and OFS. I've read everything I needed to read, and I've written everything I needed to write. So that should do it. So preserve the first 3 lines, and then translate the rest to grayscale, and it should write that file. Gray.cpp. Are you ready? So if I run this, it is a long file, so this will take a second. Got to read it all. It's several megabytes. It's not a very efficient encoding, but it's good for us. easy to read and write too. So it took its sweet time, and it did make a, well, it should have, cat-gray.ppm, so let's look at it. You know what, let's be even fancier. Let's keep going. There we go. Yeah, so here it is. Here's my program. Here's the input image. Here's the output image. So it looks like the average pixel here was this one. And we did successfully preserve the first 3 lines. So the average pixel here is apparently 28. Average pixel here is apparently also 28. So that's the grayscale version of it all. And so here's my new file, which is an image. And I can open it. You see the preview as well? How cute! So yeah, we went from here to here. We translated all the color to just shades of gray. And so that's a fun, useful example, I hope, to just, I guess, convince you that files are a useful thing to know. How to read them, how to write them. So yeah, I'll leave you with that. And exercise for the watcher, for the listener, try to make the image black and white instead of grayscale. So make every pixel only black or only white. You'll have to notice, you'll have to figure out how to tell if your pixel is closer to white or closer to black, because that's the better way to do it, okay? You're going to have to figure out which pixels do I want to make white, which pixels do I want to make black, how dark, how light, things like that. So I can give you hints if you're interested, but that's a fun little exercise for you as well. So that is, I think, everything that I wanted to say. Let's check and see if there's anything that I wanted to give out. Yeah, so there's going to be, we're ready for a lab about files, so I'll release that now, and that'll be that. So I'll see you in the lab video.